Hey everyone. So I'm just making this video to go over the Benson on Board lab in the Desmos activity. So if you were gone or maybe you were super confused in your breakout rooms, you can reference this and hopefully it helps. So the first thing we got to do is open up the Desmos activity. If I go into classwork and go down to week 4, it is 1L2 Benson on Board Desmos. So I can go ahead and open that. If you came to class, it'll have this button that says continue the activity. If you didn't come to class, you need to put your name in here. So I will continue my activity. All right, so we did the first 7 slides together in class. So this video, I'm really just gonna focus on what you are doing in your breakout rooms. And if you miss class, you can always look at the class video and it will go over. So in your breakout rooms, I either assigned you a group A, like you were taking data for an easy push, or you were a part of group B. You were taking data for a hard push. If you don't remember what you were, just pick one. It's totally fine. For this video, I'm going to use hard push. Actually, I'm going to use easy push because it's easier for me to get to. So if you look over here, you're going to be taking data for how many seconds have passed when I have gone 1 meter, 2 meter, 3, 4, 5, and 6 meter. So let me show you how to do that. If we press play on the video, I'm going to turn down the sound. You see me going. Oh, I'm going to pause the video and scroll backwards until my toes barely cross that blue line. So that's going to be my first data point. And if you look at this, that is at 0.66 seconds. So I'm going to come over here and put 0.66 in for my time for 1 meter. And then we're going to continue. So we're going to go up to the second meter. Oh, that's a little bit too far. That's pretty close. So 1.45 seconds. 5 seconds. We'll go up to 3 meters. Oh, that's pretty dang close. There we go. 2.19. 4 meters. Oh, there we go. 3.03. 5 meters. Oh, that was pretty close. 3.89. And then 6 meters, the final one. There, I would say 4.73. All right, so now that I have my data, I'm going to go ahead and go on to the graph, which is here. And Desmos is super cool because it graphs automatically for you. But what we really need to focus on is figuring out our best fit line. So we're going to take this A value, move this up so you can see it, and we are going to increase it until one of these lines, one of these equations matches our data. So we're going to increase. It looks like at this point that if I keep on increasing it, this red line is going to match my data points. So let's see if that happens. Yep. So I think that that's really close. Your goal is to have the line touch as many of the dots as possible. And I think that looks really good. So I'm going to exit out of the blue equation because we don't need that. It doesn't match our data. We're going to exit out of the green equation so that we've just got our red equation. All right, the last thing we have to do on this slide is we have to come up with our equation. And because it's not a horizontal line like our pendulum lab, it's a different sort of line. It's a linear line or a proportional line. We're going to use this equation. So for our red line, D equals A times T. So the distance equals A times time. And our A value is right here, 1.33. So if we come down here, we can write our equation D equals 1.33 times T. And that's our equation.